All right, welcome to lesson 2.3.6, which is called linear programming. And let's start off with a definition. So linear programming, I'm going to shorten the definition of this. It's simply a math technique used to maximize or minimize a solution to a set of linear inequalities. All right, so this is our definition of linear programming, and it's what we're going to use later on today. So to start with, let's do section E, which is just graphing the solution set for each system of linear inequalities and labeling all points of intersection of the boundary lines. So hopefully this looks familiar because it's just like our last lesson, right? So it should be a bit of a review, so I'm not going to spend too much time on it, but we will go over it a bit before we actually dive into the linear programming. So let's graph each of these. For our first equation, I'm going to graph that one in blue. So let's take a look at that. It says x is greater than 0. So I'm going to go over to the x-axis and I'm going to find 0 and put a dot there. And it says, well, it has x. So I'm actually going to draw a vertical line. I know we haven't seen that so often, but since it says x is greater than 0, we're going to have a vertical line. This is as opposed to the second equation where it's y is greater than or equal to 0, which would be a horizontal line. But we'll get to that in a second. So for this one, it says x is greater than or equal to 0. So I drew a solid line, a solid vertical line where x was 0. Solid because there's the equal to symbol. Right, solid because there's an equal to symbol underneath that. And we're going to shade to the right because it says x is greater than. So when it's x's instead of y's, we are going to shade left and right. So if it says greater, we're going to shade to the right. Shading to the right. Takes a while. So essentially, I just shaded the entire graph. I know. But I'm shading everything to the right. Everything to the right. Okay. Cool. So that's shaded. Let's also take a look at our second inequality. Then I'll do that one in yellow. Y is greater than 0. Okay, so for y is greater than 0, we are going to go over to our y-axis and we're going to put a dot at 0. And I'm going to draw a horizontal line. Solid or dotted? Well, this is greater than or equal to. The equal to line tells us we have a solid line. So I'm going to go ahead and draw a solid horizontal line, which is right over here. Okay, so this is what I meant between the blue and green lines. If it says x and there's no y in there, it's a vertical line, just like our blue one. If it says y and there's no x in there, that's going to be a horizontal line, just like our yellow line right over here. Okay, and then it says y is greater than, which means we're going to shade above. So I'm going to shade above, which I know is everything that's already shaded in blue, but I'm going to still shade everything above in yellow just because it tells me to, so I must. It says y is greater than, and remember, as long as your y is by itself, and if it's on the left side of your inequality, you can just listen to what the symbol says. So this is y is greater than, then we just shade above. All right, almost done shading. Please forgive me for taking a while. There we go. So now everything's in green. Okay, so we've done the first two inequalities already. Let's go on to the third one. I'll just do this one in purple. Okay, so this is in standard form. So it says 4x plus 6y is less than or equal to 72. So since it's in standard form, we have to do the intercepts and then find a tester point. So let's do that. Okay, so let's first look for our x-intercept. So I'm going to focus in on the 4x and the 72. And then to get x, I'm just going to divide by 4. And then that would be 72 divided by 4 is 18. So our x-intercept is 18. So I'm going to go over to our x-axis and put an 18 there, or put a dot on the 18. We also want to find our y-intercept. So to get the y-intercept, we're going to focus on the plus 6y. So that's positive 6y, and then equals 72. Then we're going to divide by 6. And 72 divided by 6 is going to give us 12. So on the y-axis, I'm going to have a dot at 12. And now we can connect it. Do we want to connect with a dotted line or a solid line? Let's take a look at our symbol. It says less than or equal to. I see the equal to, which is the underlined part. And so that means we're going to connect it with a solid line. Okay, so I've connected everything with a solid line over here. And then, yeah, you can see our solid purple line. And we need to figure out if we want to shade above or below. So once again, it's easiest to test out the 0, 0. So I'm going to test out our origin. And then let's plug it into our equation, our inequality right over there. It says 4x, so 4 times 0, plus 6y, so 6 times 0 is less than or equal to 72. So 4 times 0 is nothing, 6 times 0 is nothing, so we end up with 0 is less than or equal to 72. And this is true. So since this is true, we want to shade the section that has 0, 0. 0, 0 is right over here, so we want to shade all of this section. We don't want to shade up here. This is wrong, okay? So we want to shade where our 0, 0 was. So let me go ahead and shade. So in this case, we are shading below. We are shading towards the 0, 0 because 0, 0 told us a true statement. And so therefore, we want to go towards the truth tellers. So 0, 0 was a truth teller. We are now shading towards 0, 0. So that is a section we have shaded. Okay, so we got this nice, neat triangle, but we have one more inequality to graph. And so my leftover color is green, so I'm going to graph that last one in green. So let's take a look at what happens here. We have another inequality in standard form. So standard form, remember, is when x and y are on the same side. So we're going to find our x-intercept and find our y-intercept. Just going to kind of give us some space there. So for the x, we're going to focus on the 2x and the 40. Divide by 2, x equals 20. So 20 would be right over there. Let's find our y-intercept. So focusing on the 5y and the 40. So 5y is equal to 40, divide by 5, divide by 5, y is equal to 8. So on our y-axis, right over there, y is equal to 8. So then we have to see if we want to connect it with a dotted or a solid line. And we have less than or equal to, which means solid. So let's go ahead and connect those with a solid line. Okay. Sorry, let me move that a little bit. I don't think I connected that very well. Okay, right over there, to right over there. There we go, that's better. Okay, so just be careful when you're connecting it. Try your best to get it exact. Earlier I did it and I noticed it was a little bit off, so I tried again. Okay, so now it looks a lot better. And then we have to test out. Do we want to shade above or below? And I'm going to test out 0, 0 again because 0, 0 is the easiest point to test out. So testing 0, 0, which once again is the origin right over there. So 2x plus 5y is less than or equal to 40. That's our inequality. 2x plus 5y less than or equal to 40. So 2 times 0 and 5 times 0 are both 0. So 0 plus 0 is 0. We get 0 is less than or equal to 40. And this is true. So we're going to shade towards 0, 0. So we're going to shade underneath. All right, now you have to wait for me while I shade. Okay, so I finally shaded. And so hopefully you can see the section that is the shaded, or that's shaded by everything, which is, I'm going to kind of just shade it in with a black pen, just to make it like more clear. Right over here. This section is the section that got shaded. And so we have corners to this four-sided shape. One of our corners is here, another corner right over here, another corner right over here, and another corner right over there. We are going to label those points of intersection. So we're just labeling all the corners. Just to be clear, we're not labeling that one because that's not one of our intersection points of all the lines. I know the purple and the blue intersect there, but the green one actually cuts it off. So we've shaded underneath the green, so we're not even looking at this purple dot right here because this is above the green line when we wanted below the green line. So we're not labeling that point that I crossed out. Another point we're not labeling is right here. We are not labeling this point because this intersection point has actually cut us off from the right side of the graph. So this one is to the right side when this purple line has shaded everything to the left. So we don't want to include this point because it's to the right. We want everything to the left side of that. Okay, so these four dots that are left over here, these are the points of intersection that we will label. So let's label them. This one is 0, 8. This one 0, 0. Hey, look, our wonderful tester point. This one is 15, 2. This one is 18, 0. Okay, and that is it for number 1. So for number 2, I want you guys to pause the video and try it on your own and see what you guys get. Okay, so hopefully you guys are unpaused and that you guys tried it out. Let's see if you got it right. And it's totally okay if you got it wrong because remember, this is still pretty new for us. So don't worry about it. Just make sure you make corrections, okay? So I'm going to graph x is greater than 0 in blue. And just so you know, it's the same thing as what we did in number 1. So I'm going to go over this one really quickly. We're going to draw a vertical line in blue. And you want to shade everything to the right side. And still shading. Takes a while. At least for me it does. I don't know about you, but there we go. Shaded everything to the right. Okay, and then our next inequality is the y is greater than 0. Once again, we did that one in the earlier problem. So I'm going to do that one again right now in yellow. And so for this one, it's a y is greater than or equal to 0, which means I'm going to do a horizontal line at the 0. So like right over there. Let me fix that a little bit. It's lagging. Okay, it's lagging. Well, there we go. Okay, good enough. And then since it says greater than, we're going to shade above. So now we have this entire graph in green section, which is just great because it didn't really give us much more information, but it is all part of the process. It's all necessary. Okay. Almost done shading. Just takes a long time. Okay, so now that we've graphed our first two inequalities, we can move on to the juicier details, which are the last two inequalities. So let's do the next one in purple, just because, keep it consistent. So for this one, find our x-intercept, focusing on the 2x and the 20. Divide by 2, x equals 10. Okay, so on the x-axis, put a dot at 10. The y's, it says y and 20. Y equals 20. We don't even need to solve for it. It's already there for us. So 20. Put a dot at the 20. Okay, and then connect it with a dotted or solid line. It says less than or equal to. I see the equal to line, so it must be a solid line that we connect it with. So connecting it with solid line here until there. Okay. That should be good. I mean, it's a little bit off. Let me just try making it better. Yeah, okay, this part is off. There we go. There we go. Okay. That's the best I can do. And then let's see, we're going to test out a point. What point should we test out? I think you guys know what I want to test. 0, 0. So plugging it into this equation, it says 2x plus y, so 2, 0 plus 0, less than or equal to 20. So this says 0 is less than or equal to 20. Is this true? Yes. And just a clue, for most of these, when we do linear programming, 0, 0 will be true for most of the time, okay? So 0, 0 is true. We got that point, so we want to shade towards the 0, 0. So in this case, that would be shading down. Okay, so I shaded towards 0, 0. And that's our purple equation. Let's do our last one. Our last inequality, not equation, our last inequality is going to be done in green. Okay, so let me just draw a little line here. Let's find our x-intercept because this is in standard form. So we have the 2x and the 36. Divide by 2, we get x is equal to 18. So I'll put a dot over there where x is equal to 18. Let's find our y-intercept. We got the 3y and the 36. We can divide by 3. We get y is equal to 12. So over here on the y-axis, put your 12 there. And then do we want to connect this with a solid or a dotted line? Take a look at our symbol, less than or equal to. Because it has the equal to line, we must connect it with a solid. So solid line from there until there. Okay, and I think I did a decent job that first time. I don't need to adjust. And then we're going to do a tester point. Once again, test 0, 0, as usual, my favorite. And then, like I said, most of the time it's going to be true. But let me just show you how it will be. So 2x plus 3y, 2x plus 3y is less than or equal to 36. So 0 is less than or equal to 36. That's true. So we want to shade towards the 0, 0. once again, you just have to wait for me to shade. Shade everything under that green line. Shading, shading. Everything towards the 0, 0, because 0, 0 told us a true statement. And like I said earlier, when we do linear programming, most of the time 0, 0 will tell us the truth. So you just want to shade towards 0, 0. Okay. Finally, we want to figure out which part was actually intersected by everything. So let me just highlight it for you so that you can see. I'm going to just do the same thing I did in number 1, which is just draw black lines. I think it just makes it more clear that this part is intersected by all 4 inequalities. And so let's label all the intersection points. We have this one, this one, this one, and this one. Labeling them, we have 0, 0, 10, 0. That is a 6, 8, and that one is a 0, 12. And there we go. So now we've labeled all points of intersection of the boundary lines, and the solution is everything that's with those black slash marks, okay? Okay, so if you have any questions, please call me over into the breakout room so I can help you guys out. I'll see you in the next video.